Good morning, everyone. Imagine waking up tomorrow and finding your electric bill doubled overnight. Your gas prices spiked up once again, from $4 to $5 on regular. These power outages becoming more common. But there is a solution. It's green energy. One that doesn't harm the planet and is technically free. Your empty field can be full of solar energy panels or wind power, generating free money and free energy. Your home can have solar panels on top, powering its home to reduce that electricity bill. Your neighbor might not have electricity, but you will. Your neighbor might be struggling because they can't buy gas for their car, but you can run it off your solar panels. And over time, those solar panels and renewable energy, it pays itself off. So after it pays itself off in 8 to 10 years, it's basically free. And you're making passive income. You don't have to do anything for that money. Our system is an all-electric heating system for New York City schools, but it can be sized down to your needs. This works for a school that's 5 stories high, but it can be brought down to the level that you need. Our system has solar panels that is net metering to the grid to help pay off the electricity bill. We have a lot of geothermal boreholes that go 450 feet down and is able to provide 80 tons of geothermal energy, enough to supply the entire building. And using geothermal heat pumps, we're able to get enough heat to the air handler units and also the radiators to spread heat across every floor to the set temperature that we desire.
Okay. Hello, we're Group 6, Ethan,
Bart, and Joey.
This is our senior design prototype that we have. It's a solar PV system with two 120-watt solar panels in series, connecting it to a 40-amp charge controller, 100-amp hour battery that's 12.8 volts, a 1,000-watt inverter, and a small AC load that calls for 0.25 amps, 120 volts AC. So to record our data, we're basically going to conduct two trials. One for 30 minutes where we're having both panels working in series and we can read the data from the charge controller and inverter that we'll show you in a second. And another trial where we'll have one of these panels shaded so we can see how the MPPT voltage will change based on the charge controller to maximize power going into the battery. And if you want to see how we record our data, from this charge controller, we can read the voltage that the panels are sending in to the charge controller. We can see the current that the charge controller is sending to the battery. The current that the panels are operating at is 4.21 amps for IMP. This doesn't necessarily show you that. We can see the operating temperature of 31 degrees Celsius. And we can see that the charge capacity right now is at 0, but it's turned into 1 actually. In a couple minutes, it'll hopefully go up to 2, 3, 4, 5 as we continue our trial. And our inverter, we can also read some data from here. We can see that it's 13.2 volts, 13.3 volts DC input and 120 volts AC output at 60 hertz like we expect. And that's able to power our fan that you can see is spinning. So our prototype is successfully working. And we can see in the back that it calls for 0.25 amps and 120 volts AC. We could charge some more loads into here. We could charge some more loads in the charge controller, but it's not necessary for now. And we'll again conduct both trials for 30 minutes and analyze our data afterwards. But just to quickly show you for the second trial, if we decide to shade one of those panels, okay, you can read that the voltage has dropped. The VMP for one of these panels is about 28.9 volts, so you can see the volts operating near that range.